There's an important difference between the loops you may have seen in other languages and what we have in DAML. Variables in DAML are immutable, so we can't use loop constructs such as a while or for loop because we don't have variables that can change their value iteratively. We're going to look at 3 ways you can perform iterations in DAML using recursion, map functions, and finally the use of folds. In a recursive function, the function calls itself with an argument value different from what it was called with previously. It's often used in mathematical definitions of functions, for example, in calculating a Fibonacci number. The mathematical definition of a Fibonacci function is that given n, it calculates the sum of the last 2 numbers in the series. For example, the sum of numbers at the position n-1 and n-2 in the series. So to compute Fibonacci n, you need to compute Fibonacci n-1 and Fibonacci n-2. The function recursively returns until you hit the base case or edge case for n equal to 2, or when the function simply returns 1. The code here shows the Fibonacci function implemented using guards. If n is less than or equal to 2, the function simply returns 1. This is the base case. If it's any other number, it calls the Fibonacci function twice, first with n-2 as the argument, and second with n-1 as the argument. Each of these calls recursively goes back until it hits the base case and delivers the final results. Recursion is often easy to read, but hard to implement in code. So if you find this difficult, there are other ways to perform iterations in DAML. DAML has functions that we can use to iterate over a structure such as a list or a set. One such function is map, which takes 2 inputs, a function and a list, and then it applies the function to each element of the list and returns a new list. The example here demonstrates creating a function called modulo using map that takes a list of ints x and an int y. It needs to return a list that contains modulo y of each element in the list. So it uses the map function, which takes modulo y as the function and x as the list. When the function modulo using map is called in the debug statement below with a list and a number 3, the result is a list where each number is taken at a time and computed for modulo 3. Let's look at the third approach to looping in DAML using folds. Folds are similar to the map function, but with an accumulator. Map functions aren't well suited for cases where iterating over a list you need to use the result of the previous iteration. Folds work well for this use case. With each iteration, they store the result in the accumulator and then use it in the following iteration. DAML provides several functions that perform folds to iterate over a structure such as a list. The 2 we're using in this example are fold_L and fold_R. The former iterates over a list from left to right, and the latter from right to left. A fold function takes 3 arguments, a binary function, a starting value for the accumulator, and a list. It starts with the initial value in the accumulator. It then takes a value from the list and applies the binary function to the 2 values. The accumulator continues to collect the result of the function until all list elements have been covered. It then returns the final value of the accumulator as the return value of the function. In this example, let's look at SUMList. Its signature shows that it takes a list of ints and returns an int. In the definition, it has fold_L followed by the plus operator enclosed in parentheses. The plus symbol is usually used as an infix function, but when we enclose it in parentheses, it works just like a regular function or prefix function, where the function name comes first, followed by its arguments. Then we have 0, which is the starting value of the accumulator for fold_L to work with. With this accumulator, fold_L adds each element in the list x, starting from the left. In the script below, we pass the range list 1 to 4, and it prints 10. Now we know there is already a library function called sum that does this. So let's look at a slightly different example that uses fold_L. The second function here is list_to_text, which takes a list of text and returns a flat text string. Following the same approach to parsing fold_L statements, we name the function that needs to be applied to each element in the list, then the initial value of the accumulator, and then the actual list. Notice that the function to be applied here is actually a lambda function that takes 2 parameters, ACC, which is the accumulator, and y, which is an element. It concatenates ACC with show y. Since the value in y is going to be an int, we need to convert it to text by using show. So the fold function will take an empty string and the first element of the list, pass them to the lambda function, and store the return value of the lambda function in the accumulator. Then it will take the value of the accumulator and the second element of the list, pass them to the lambda function, and update the value of the accumulator with the return value of the lambda. This process is repeated for the remaining elements of the list, and then the final value of the accumulator is used with the return value of the fold L. When you call this function with the same range list 1 to 4, you get the list flattened as string 1, 2, 3, 4. You can replace fold L with fold R and switch the position of the accumulator and element. This change will help you get the reverse list to text functionality. So let's look at what we've covered. We've looked at writing code that can be repeated using recursion, maps, or folds. Recursive functions call itself in a definition and need a base case to make an exit. Map takes a function and applies it to a list, returning a new list that contains the result of the function application to each element of the list. Fold does a similar thing, except it takes a binary function in addition to a list, and it also takes an initial value for the accumulator. At each iteration of the list, the binary function is applied to the accumulator and the current element of the list, and the value of the accumulator is updated with the return value of the binary function.